Good evening, everybody. Welcome to Advanced Electrical Networks. This is lecture 51. In the last class, we were looking at Good evening, everybody, and welcome to Advanced Electrical Networks. This is lecture 51. In the last class, we were investigating the analysis of weakly nonlinear circuits, and we saw that we could write the output V out as the sum of a linear term, a second order term where so it's terms due to the second order, and VO3, which basically is due to terms of both, including both the second and third order, and so on. And if the input is scaled by, so if this is the output in response to V in of t. Now, if V in of t is scaled by a number z, then V out of t will be also changed, but the linear term will be scaled by z. This will get scaled by, the second order term gets scaled by z square, and the third order term will get scaled by z cube. Right, etc. Then we saw that basically this approach, where you split up the output into something which scales as z, something which scales as z square, and something that scales as z cube, is basically avoiding solution of a nonlinear differential equation. And instead replaces it with multiple solutions of a linear network. Okay. So, today let us take some simple examples and see that convince ourselves that this indeed works. So, we will take a block diagram representation of a feedback system. So, this is V I, this is V out, all right, and well, this is the error, and this is some function of the error, right. So, if f of V e is simply, or let me call that g, because we have already used f for the feedback factor. So, right, if g of V e is nothing but A0 V e then this is nothing but a linear feedback system, and V out by V I is nothing but 1 over f times A 0 f by 1 plus A 0 f. That is a very well known formula, and this A 0 f is the loop gain. And you do the math, and right, and as A 0 f tends to infinity, the closed loop transfer function becomes independent of the loop gain and only depends on the feedback factor. All right. Now, the question is, what happens when G of V E is nonlinear? So, it's, let us say, it is A 0 V E plus actually, I am sorry, just let me change the notation a little bit. Let me make that A 1. So, this becomes A 1 and this becomes A 1. So, the next question is, what happens when you have G of V E is A 1 V E plus A 2 V E square plus A 3 V E cube, right. And typically, there will also be higher order terms, but we will neglect the stuff beyond the third order. Okay. So, the hard way is, what is the hard way? I mean, remember, here there is no memory of any sort, correct. So, everything is memoryless. So, well, you just only get, you do not get nonlinear differential equations, you get just nonlinear equations, right. So, what would you do? Well, V I minus f times V out equals V E, and V E equals, sorry, and V out equals A 1 times V E, which is V I minus f V out, right. So, this is V E plus A 2 times V I minus f V out the whole square. This is V square plus A 3 times V I minus f V out the whole cube. So, this is V the whole cube. Okay. What we are interested in is, we want V out to be of the form something into V I, right, plus something into V I square plus something into V I cube, right. And of course, if A 2 and A 3 was 0, then it is very straightforward, right. This we can find it's a linear equation and you can find the unknown. But now, because of these V out square terms and the V out V I term, and you have a whole bunch of cross terms, right, finding these terms, right, is very messy, and right, and if you are not convinced, you can try it out on your own. You basically, you as you can see, to solve for V out, you have to solve a, I mean, you basically end up having to solve a nonlinear equation of the third order in V out, and it's very painful, right. Now, we can do something simpler based on our knowledge of current injection. So, what is the premise? V out is nothing but VO1 plus VO2 plus VO3 etc. correct, and what is, and remember that G is nothing but A1 VE plus A2 VE square plus A3 VEQ. All right. Now, finding VO1, what do you do? So, to find VO1, what we will do is consider only the linear term. So, this is the A1 VE, right. So, this VE in this circuit is also VE1, right. This is F and this is VO1. And that is very straightforward. VO1 is nothing but 1 by F times A1F by 1 plus A1F. Okay. And what is VE1? The easier way to find out is we know VO1, that divided by A1 is VE1, and that is nothing but 1 by 1 plus A1. Okay. Oh, sorry. VI, this times VI. Correct. So, we found everything that there is in this network. Now, the next thing is find VO2. What do you do now? Well, we set the input to 0. And what should we inject? We have, this is going to be VE2. This is going to be A1 times VE2, right, and we have to inject the current of VE2 time. We have to inject, what are we supposed to do?
We have to inject the current of VE2 times V of 0. We have to inject the some current that is proportional to the V of 01 minus V.
So, basically you inject VE1, so that is basically you inject A2 VE1 square. You understand? Okay. So, and and this is VO2, correct, and so what is VO2? What is it? I mean, this is a linear feedback loop and you are adding some error here. So, what is the transfer function from there to the output?
That input into 1 by 1
Yeah.
plus A1.
So, this is nothing but A2 VE1 square by 1 plus A1 F, right, and what is that? Well, A2 times VE1 is nothing but VI by 1 plus AF A1F. So, you have to square it.
And 1 plus A1F whole cube.
You get 1 by 1 plus A1F the whole cube. All right. And as we expect, if you double the amplitude of Vi, this VO2 will go up by a factor of 4. Okay. Now, what did we say was the next thing is find VO3. All right. So, what do we do? How do we figure this out?
We have to inject the two more another current source, like two current sources at the
This is VE3, this is A1 times VE3, and we have to inject something here, right. And what was the stuff that we were supposed to inject?
like A2 times A2 times V error 1 into V error 2. Like there we have to inject two more currents. One is A3 times V error 2 whole cube will come. And another current will be A2 times V error of 1 times V error of 2.
Let's go back to our notes. As you can see here, you have, when we go back to our notes here, you can see that what did we do in the second order term is straightforward, right. We basically did G2 times all the second order current that is flowing. In the third order case, right, of course, the cubic term is very easy to understand, correct, but you also need to what do you call you also need to have a second order dependence, right. And what is the second order dependence that we have? So, this is, if you stare at this picture, so you have a component which is VO1 in the what do you call in the third order network. This term is easy to understand, correct, that is simply the third order nonlinearity, right. So, you also need to have VO1 minus Vi times VO2, right. So, that is basically what is this? This is in our context, this corresponds to the voltage. This correspond in our context. This corresponds to V error 1 times V output 2. Okay. So, and then there is a factor 2, that is the cross term, right. So, this should be 2 times G2. Actually, this there is yeah, this is fine. This must be 2 A2 times V error 1 times V O2, correct, and plus A3 times V error 1 the whole cube. all right. And the sanity check is that VO2 goes as, I mean remember that VO3 must go as Z, if you increase the input amplitude by a factor of 2, VO3 must go as a factor of, by a factor of 8, correct. And well, V error 1 cube, V error 1 directly proportional to the input. So, therefore, if you double the input, V error 1 the whole cube will go, V error 1 will double, and V error 1 the whole cube will go up by a factor of 8. V error 1 of course is directly, if you look at this term, V error 1 is directly proportional to the input. VO2 on the other hand is proportional to the input square, and therefore, this whole product will go as by a factor of 8, right. So, that is the sanity check. Whenever you are in doubt, you got to make sure that in the third order, what do you call, to find the third order response, what you want to do is make sure that if you double the input, the second order response must go by go as z square, I mean as 4, and the third order response must go as 8. So, what do we see here now? So, VO3 therefore must be equal to 2A2 times VE1 VO2 plus A3 times VE1 the whole cube by 1 plus A1F, okay, and which therefore is nothing but (2A2) VE1 is already known, that is nothing but VI by 1 plus A1F, right. VO2 is nothing but VI square. So, the whole thing becomes VI cube times A2, right, divided by A1F the whole cube. So, when you we can simplify that later, plus A3 V1 cube is VI cube by 1 plus A1F the whole cube times, there is already a 1 by 1 plus A1F. So, that becomes to the power 4. So, this is nothing but 2A2 square VI 2A2 square plus A3 times VI cube divided by 1 plus A1F whole power 4. Am I missing something?
One factor will be there, 1 plus A1F. Like if you take the first term, already 1 plus A1F is there in the output, sir. And from the V error 1, we will get 1 plus A1F.
Correct. That is why I have
like therefore A power 5, whole power 5 will come there.
V error 1 is basically
we get 1 plus A1F, and because of V error, V output 2 will get
V error 1 is 1 by Vi by 1 plus AF, that is correct. VO2 is the cube.
VO2 you will get to cube will get, and another term will be there in the output by 1.
Oh yeah, indeed, that is right. So, let us just do this properly. So, this just becomes 2A2, V error 1 is nothing but 2A2 by 1 plus A1F times V error 1 is Vi by 1 plus A1F times VO2 is nothing but A2 Vi square by 1 plus A1F the whole cube plus A3 times Vi cube divided by 1 plus
whole power 4.
A1F whole power 4. Right. So, basically this is nothing but Vi cube by 1 plus A1F whole power 4 times 1 plus A3 plus 2A2 square by 1 plus A1F. Okay. Just checking if there is some dimensional inconsistency, we are okay. A1 A2 square I'm missing something, hold on. See, A2 V square has got dimensions of voltage, A3 V cube has got dimensions of voltage, so that's all fine. So, when we come here, what have I missed something here? A3 Vi cube is fine, A2 this AF, V1 Vi1 VO2 is A2 Vi square is voltage, so A2 Vi square is voltage, Vi is voltage. So, so this into A2 Vi square is voltage, has got dimensions of voltage, correct? A2 Vi is yeah, A2 Vi is dimensionless, correct. A2 Vi is dimensionless, so we are okay. All right. Okay. So, therefore, V out is nothing but the linear term, which is VO1 plus VO2 plus VO3, which is
A1 by 1 plus A1F.
This is nothing but A1 F by this is A1 by F times A1 F by 1 plus A1 F times Vi plus A2 by
1 plus
A1 F the whole cube times Vi square plus A3 plus 2A square by 1 plus A1 F times Vi cube by 1 plus A1 F whole power 4 and so on. Okay. So, for large loop gain, correct? What do you think will happen to this? This is approximately
equal to first linear.
no.
That is A1F.
A1F is very large. What comment can you make about A1F by 1 plus A1F?
That is 1.
That's 1, right? So, this is basically approximately 1 over F times Vi, correct, plus A2 by A1f the whole cube times Vi square plus A3 plus 2 A2 square by A1f times Vi cube by A1f whole power